Good evening, everyone. In this video, we will talk about branchless programming. And basically, what branchless programming is that let's say you have a branch, and a branch typically in languages is just like an if statement followed by else statements or else if statements, but it just basically means like if you have a conditional. And what branchless coding means is that you have a sort of if statement and you want to boil it down to just be something that doesn't include that if statement. And with doing branchless programming, you end up writing neater code, and usually in some forms of branchless programming is actually a lot more faster, and most of all is a lot more readable. Now, for our first example, let's say we have a test part in workspace, which is this part right here. And what we want to do in the script is that if the test part is anchored, we want to change the color to green, and if it's not anchored, we want to change it to red. So let's just see if the code works. It's not anchored, so it should turn red. And if we run this, it turns red as expected. And if we anchor it to true, it should be green. Now, this code in itself is fine, but as you see, we use 7 lines. We use 7 lines to just do this simple task. And what we can do is we can change this branch and make it something in just 1 line. I'm not saying like just deleting the tabs and making it like that. That just makes it like even worse. What we can do instead is we can use a ternary operator. And what ternary operators are is that they basically check if one condition is met or true, and it would run or it would output a specific value, and if that condition is not met, then it'll output another value. This is usually modeled by if A, then B, else C. So to write some code here, we can do test part.color, and what our condition is, we want to check if it's anchored. So this conditional should output either true or false. So you can put that here, and also we don't even need this equal true. If we just leave it as is, it should still do the same thing. So we can actually remove that. And firstly, I actually want to show you the old method, and then after showing you the old method, I can show you the new method in which Roblox provides. So the way the old method works is that we have our condition, then we have our next value, which would be B, following the if A then B else C. So we have our condition if the test part is anchored, and our first value, if it is anchored, we want to turn it to green. So what we can do is we can put and then we can have the green color. And then the next thing, or our next value, if the condition is not met, is red. So what we can do is we can do or, and then we can turn this red. And we don't need this. We just cut all of this and turned it into 1 line. So let's just run this line by line. So first, we have the variable test part. Okay. Test part is in the workspace. Awesome. Then what we do is we set the color, and then now we get to this part. So the way this and this or works is that when you have an and, it tries to select the last value it has, or the operand on the right. So if the left side is false or nil, the whole condition will be nil. And what this means is that, let's say the test part anchored, the anchoredness of the test part is false, then this condition will be nil. And if this condition is nil, then we have this or operator here that will basically tell us that if this operand is nil, or if this operand has nothing on it, then we just check then we just select the next option, which is this red color right here. And this red color, of course, is not nil, so it's going to select that instead. So if it is anchored, then it will turn true. Then we're going to the next operand to check if that condition is also true. So we can see that this, of course, is not nil or not false. So this is going to select it. This is going to select this green color. So this condition will output the green color. And since this OR operator just needs one of either or, it's going to select this one over this one. So if we run this right here, we can check that it, of course, functions normally and as expected. It's anchored. We see it's turned green. And then if we unanchor it right here and run it again, we can see that it turns red. Now, to make this a lot more pretty, because this is still somewhat unreadable, is we can use the Roblox keywords, which makes it a lot more intuitive. So we have the Roblox ternary thing, which is if, and we have that condition, and then we can do else. If then, our first option, and then we have else, which is our second option. Now this still works as intended. Boom. And this is, in my opinion, a lot more easier to understand than the and or thing, because then that makes the reader of the code have to understand what that means, and this just makes it a lot more easy to understand for people that don't know what a ternary operator is. They can just intuitively understand that this is just doing what it's doing. So we can leave it as is, or we can make this cleaner and add variables for this, but let's not do that, and let's just move on to our second example. So we have our second example. We have a function called hasDecimal. Basically, this function has the parameter of a digit, and what this function does, if it checks if when you truncate all the decimals, if it's equal to d, oops, my bad, and if it's not equal to itself, then that means that it has decimals, I'm pretty sure. Wait, math.floor, okay, so let's say it has a decimal. It will floor it, it will not be equal to it, and it will turn false. So I think these are flipped. Okay, so let's just say we have this function. It has if it has a decimal, it will output true. If it doesn't, it'll output false. And then we have these print statements to check if it actually works. So let's run that. So it should output false, true, true, false. Awesome. So we see something so simple already covers up around 7 lines, and we can make this into something a lot more branchless. And what we can do is we can take our understanding from the first example and say that this condition always outputs true or false. When you have an equality operator, it will always output false or true. So we can use that to our advantage and just return that conditional, because it's always going to be true or false. It's going to go already return what we want. So what we can do is now we don't even need the conditional. We can just do return. And of course our thing was wrong, so we have to do the not equal to, and this should work the same way, which is awesome. So now that our second example done, we have another instance of branchless coding, and we have this with tables. So right here we have a function. Now this function takes in an item, which is a part, and it checks if the name is either leaf, rock, or tree, and if it does have those names, it will assign the color to them respectively. Now this in itself, yeah, it is kind of readable, but it looks like I'm repeating myself a lot. I do item.name, item.color, item.name, item.color, and imagine if I had 5 more of these. This will just be absolutely disgusting. Or if I want to change another property, oof, that will just be no, just like no. Okay, so to fix this is we can use our other method, which, okay, yes, we can do the ternary operator here and just like stack it multiple times, but that's gonna look majorly ugly. So what we can do is we can have a table that will just basically be a dictionary, and what we can do is we can like hash or index that dictionary to check if it's a thing we can assign the color to, and then that value of that index will give us the color. So let me write down what I mean. So let's have our dictionary, let's just call it map, and we can have the indexes be the names we want. So we have leaf, and this, we want the color of the leaf to be green. Awesome. And then we want the rock, we want the color of the rock to be gray. Boom. And then lastly, we want the color of tree to be brown. So now that we have this, we can simply just do item.color is equal to our map, and then we try to look for the assigned name. So we can just do item.name, and if we run this, we should see that it will go to the function. Boom, it will change the color, it will see if it's in the map, and then it indexes or tries to look for the name of the item inside this map we have, and it will give us the value of the color we want. Yes, but if we run this, we will see that this in fact errors, and the reason why is because we have to add another guard that if statement was giving us. And the way we do that is we just check if our dear item name is in the map. So what we can do is we can just do if we have a color. If we don't have a color actually, then we want to just return. And this in itself is called a guard clause. This is just to protect our code from any errors that might happen. And this doesn't indent our code, and it makes it a lot more readable and nice. And as we see this, it does not change the color, surprisingly. Let's check our code. So we have that. Boom, boom. Ah yes, I forgot dot name. Silly me. Now if we run this, boom, works as expected, and we have our code be branchless, and we can expand this basically forever without ever having to gauge our eyeballs into seeing the amount of branches we have. It's just a lot more better, really. So we can stop this, and enough of the examples. Let's move on to some practical examples. Now, for our first practical example, we have something that I see a lot. So actually, let me scrap this. So what we want this code to do is we have our player. We get our player from Surge UI. I mean, we have our script in Surge UI, but we go up enough until we see a player, not players, and then we try to get the character and print the character. But since this is a script, or actually this will happen more in local scripts, but since this is a script, more often than not character is going to be nil. So what some people try to do to stop this is they try to do something like repeat wait until player.character, and this in itself is really bad. This is called polling, when you try and do a loop and wait multiple times to check if a condition is met. And what some people try to do instead is they try to have this hooked onto something like an event and use the wait function that will just do this automatically for them. So they can do player character added. So, and this character added is an event, so it's going to have the wait, and this basically waits until this event fires. But of course, sometimes the character is already loaded, so it's gonna wait until the character is added again, and sometimes the script is just not even gonna run. So what some people try to do is they try to only run this if the character is not there. So let me just write this out. But right, player, that character. But of course, we can do a lot more better. This is a branched way of doing this, but this is a branchless programming video. So what we can do instead is we can use a way or a method that is a lot more better than doing this. So let's just remove our branch, and we can go back to our and or statement that I taught you in the first example, and we can use it again here. So what I mean is that, let's say we have the player, the character. Let's say it's not there. What we can do is we can go to our other option using this or thing. So what this or conditional is gonna be doing is it's gonna check if this option is viable. If it's not, it's gonna move on to the next option. And what our next option is gonna be is it's gonna be the player, that character, wait. So if our character is not there, it's gonna move on to the next option. This next option is gonna wait for the character to be added, and once that happens, it's gonna go to this or thing again, or this or condition again, and it's gonna check these two options, and now player, that character is gonna be added into the game. It's gonna be it's just gonna be added, and then we're gonna be able to get our character nice and neat. And we don't have to use any other polling, we don't have to use a branch, and this just makes our code a lot more nicer and readable. Now, our other practical example, and get ready because this is a long one, is a dash script. Now, isn't that beautiful? All right, let's just see if our dash script works. So if we hit play and wait for it to load. Let's have it shift, and then we cue the dash. Awesome, it works. It has a cooldown even. Awesome. So now when we see the script, we see a lot of things happening, right? We see a branch, another one, and then we see ourselves repeating. Now what we can do instead is we can have a mix of our third example and have a table. So to make this readable, we can convert this branched coding into a map. So let's do that first. So we have our map. We have our inputs. Right? Yes, we have our inputs. But let's see, cause the main thing about this is that, let me run this again. The main thing about this is that if I not in shift lock and I go to the left and dash, it's gonna move me respective to the character. It's gonna move me respective to the keys I'm pressing. So since I'm pressing the A key and dashing, it's gonna think I'm moving to the left, like shift lock, like this. But I'm not. I'm moving and forward, and it thinks I'm moving to the right, and it's just gonna look weird. So what we can do instead is we can check the direction it's going relative to the direction it's walking, and the way we do this is with the dot product. So yes, it's gonna be a bit more advanced, but this is very practical, as this dash thing I see so much in scripts I read, and I just hate it so much. So let's do this. So we have let's make a variable called there, and we can have this be the direction it's going. So we can just exclude the y axis, and let's just focus on x and z. So the way the dot product works is we have two vectors that we input into it, and a very simple way of understanding what it does is that it gets the angle it gets the angle that those two vectors make. So let me open MS Paint real quick. Let's say I have a vector going this way, and let's say I have a vector going. Alright, let's say we have a humanoid here, or a humanoid root part. I'm not an artist, okay? I'm not an artist. Let's say I have a humanoid root part going here, and let's say this is the direction. If this is the direction they're looking at. If they're going this way, and we get the dot product of both of them, we can check that the angle is this. This is what the dot product is gonna give us, and this is very important because if it's all the way to here, we know that they're going to the left, and this dot product angle is gonna be I think it's gonna be like 1, maybe 0.5 or something like that. And if it's going this way, it's gonna be negative, I believe. It's gonna be negative. And then if it's going down, we have another dot product. I think we can use what is it called? The right vector or left vector, and we can use it to get that angle too. So let's move on and let's check. We have our root part variable already. Awesome. And we can get since this is x, this is going to be left and right. So actually let's just test what the dot product will give us. So if we print, let's have a variable for the humanoid. Awesome. And then with this, whoops, misspelled humanoid. We have that humanoid.move direction. Yes, that is a property. And then we have root part, C-frame, look vector, and then we get the dots of that. And the look vector should have a magnitude of 1. Move direction should also have a magnitude of 1. So let's see what it gives us. Yeah. Alright, let's say if we go forward, this should output 1. If we go back, output -1. Okay, that's interesting. So this can be used to get our z-axis because z is front and back, right? And if we go left and right, that's going to be like very close to 0. Okay, so my diagram here is not perfect because the way the dot product works internally, I think, is if it's super close, it's gonna be close to 1, but if it's super far away, like pointing opposite direction, it's gonna be -1. Right, because I believe the max of the dot product is 1, and then the minimum is -1, and that's if both vectors are normalized to have magnitude of 1. So now that we know that we can use this for the x-axis, we can just plop this here, and we can also plop this here, and now we know this will be the right vector. Now let's just print our direction. So go forward, it's going to print 1. Awesome. If we go left, -1, as close to 0. That's perfect. Go here, boom, and boom. Okay, works perfectly. Now as you can see, we have a little bit of a decimal floating point error, and what we can do to fix this is we can just round it, and it's actually going to be a lot more better because then we can put it to our map because it's going to be directly hashed into this, which is awesome. So we can do math.round, wrap this here, boom, boom, and this should give us it practically perfectly. So forward, no decimals, awesome, no floating point errors, exactly what we like to see. And if we move to the left, this should output 001 because we're going forward. Awesome. And don't be tricked by the direction I'm moving. That's just the old um, dash script. So now that we have our direction, we can map it onto here. Now, instead of having the name of the item like we had here, we're going to have the vector of the direction. So as we know, forward is going to be 0, 0, 1 as we tested before. So we can do vector.new and then 0, 0, 1. And of course, since this isn't something like a string, we have to wrap this in brackets. Okay, now that we have that, we're going to have to make this equal to value. And, well, oh wait, actually, since this is relative, we can just hook this onto here. Oh, that is awesome. Yeah. So if we have this be the direction, we actually don't need any of this code right here. So if we remove this, let's just test this out. Boom. And let's get rid of this map. I thought we needed it to oh yeah, we might need it to make sure it's like not going anywhere or something like that. Alright, let's check. Okay. So let's say I'm moving to the left. Q. Oh yeah, it's because the way I had it before is I had it be times 100, I think. Let me go back. Yeah, I have 0, 5, and a negative 100. So what I can do is I can do times 100. And I want it to go up a bit so it doesn't like drag on the floor. So I can do vector.new 0, 15, 0. Or I could do y-axis and times 15. But this is just a lot more readable in my opinion. So let's hit play. Boom. We're in. If we go to the left, dash. It's going it's going the wrong direction. Let's see if we go to the left. Okay, that's at least going right. Oh, I'm pretty sure it's because the attachment is flipped. It's actually going this way. So let's go back. Whoops. And we can just put this negative. Awesome. So boom, boom, boom. Oh wait, I should have it not shift lock. And yeah, seems to be working pretty well. Oh, and since we have it like this, I think what we can do is if our direction, if the magnitude of our direction is equal to 0, so if all of these are 0, making the magnitude be 0, we can just return. And in my opinion, I like to make these short ones into one line, and it should basically not do anything if we don't move. I mean, I wasn't gonna do anything beforehand because it's gonna have a vector velocity be 0, but just to make sure, just to have like a safeguard, we just have that. I'm pressing Q, nothing's happening, so that's pretty good. So now I have remembered the reason we need a map is that let's say you have something like an animation that you want to play for every single one of these dashes. What some people might do is they have animations here. I would have them in replicate source, but just for this sake, I have it here. So forward, backwards, left, right. And what some people do is that they just have a branch like this, and they see it's going forward, or actually in this case it will be like that, and then they would do that, get the humanoid animator, and then they will do this multiple times like that. Whoops. And then it would just look very ugly in the end because you have a lot of these branches, and even though it might work, it's not gonna look the best in terms of all these branches and indents. What we can do is we can convert this to a map, and this basically follows the same pattern as our third example, but instead of it being names, we have vectors. So we can just follow what we did here, and we can even load it in the beginning, which is a lot more better. So we can do this, misspelled animation, oopsies, and then we can just do that, and that. Or negative, 0, -1. So this would be left, this would be right, this would be forward, this would be backwards. So we have our map, and instead of doing all these branches, we can just have our map. We can index the vector we have, so our direction, and then we can play it. Awesome. So let's just make sure this works by printing the name. Oopsies. Uh-oh. Backwards? Oh, right, since it's a local script, I have to do wait for child. It's gonna look ugly, but can't really do nothing about it. And this should be the last one. Boom. Awesome. Forward, left, back, and right. Uh-oh. Well, it would have worked anyways. We just probably did something wrong. Okay. All right. Didn't print this 0. Okay. Now that we finished our second practical example, you should now be a pro at branchless programming, and I just want you to look at code or your code that has any sort of branches and try to figure out any sort of way that you might make it into something that isn't branched and be a lot more neater and sometimes even a lot more optimized. But yeah, that should be it. If you need anything, post it in the comments or you can message me. That is all. Peace.